So let's discuss the problem the day of the lead code. And in this problem, we have to find the peak index in a mountain array. So what do we mean by peak index? That first of all, you should notice that index should be greater than 0 if we are following zero based indexing, and should be less than n minus 1. Means either it should not be the first index or even the last index. Okay, and it should follow the properties like this. Array of 0 means mountain array would be something like this. Okay, it is 0 and it is somewhere I here, and n minus 1 means till I all the elements will be in the increasing order, strictly increasing. Okay, it has been stated that it should be strictly increasing, and after I it should be strictly decreasing. Okay, so yeah, and one thing also, you have to solve it in big O of log n time complexity. Although we will not move to it directly, we would just first discuss the brute force and then the better approach and then the optimal one. Okay, so what would be the brute force? Obviously, I would just do do the brute force just as the condition has been stated. Means at each index I will just check whether it is following the increasing property in the left and decreasing property in the right. If it is so, then that is the mountain index. Okay, and it has been guaranteed that there exists to be a mountain array. Okay, there always exist. So if you just give an input like this, then it will be an invalid input, because it has been guaranteed that it will be a mountain array. So the array should be look like this only. Okay, it has been ensured by the question provider. Okay, so let's first code the brute approach. In the brute force, I will just do the same as the condition has been stated for a mountain array. Since 1 can not be our answer, so I will start from I is equals to 1, I less than n minus 1, I plus, because the last index can also not be a mountain index. Okay. Now, for each of the index which I am at present, I will just check whether it's following the condition or not. Okay. Let's bool is equals to true. It will just say whether it is following or not. J is equals to I minus 1, j greater than or equals to 0, j plus plus, j minus minus, means checking on the right. Now, what should be the condition? If ARR of if ARR of j is greater than ARR of j plus 1, then obviously it is violating, because it should be the strictly increasing in the left. Okay, so I can say okay is equals to false and break. Okay, and if I can say if okay, if not okay, means I have already violated the condition, then there is no need to check on the right. So I will just continue. Now, if it is true on the left, then I should also check for the right one. If error of j is less than error of j plus 1, then obviously it is violating our condition. So if finally, if okay, if all the things are, all the condition has been met, then this is our answer. Let's run it. Why runtime error? Okay, let me figure out. Okay, n minus 1. Okay, it is fine. J is equals to I minus 1. J greater. Oh, sorry. It should be j greater than equals to 0. Okay. J is equals to I plus 1. Oh, sorry. It should be like if a of j means, suppose if I was at this index, if I was at this index, then what should be the, because 1 was the mountain array, so it would mountain index, so it was having the, it should have the maximum value. So if ARR of j minus 1, then this should be, then this is the violating condition. Okay, so it is giving right answer. Let's submit it, although it will not pass because it will lead to DLE. Yeah, as expected, because it is n square solution, which will obviously not pass because n is quite high, 10 to the power 5, so n square will be 10 to the power 10. So now how to optimize this? One thing you should note here is that what we are doing wrong means what we are doing extra in this. Do we really require to run in the left and in the right explicitly? Obviously not. We can store, we can do some pre-computation to do this in big of one time at each index. Okay, let's see how. Suppose this is my index, suppose this is my array. Okay, so what I will pre-compute, I will pre-compute a prefix array and a suffix array. What the prefix array will, prefix of I is, will tell that what is the maximum increasing, means the number of the element which are increasing order till now. Suppose it was 0, okay, 1, then it was 1, then it will become 2 because obviously 1 is greater than 0, so now 2 is greater than 1, so 3, 10 is greater than 2, so 4. And after this, all the elements, since these are all in decreasing order, so it will be 1 at each index. Similarly for the suffix 1, I would just start from the right to left, 1, 2, 3, because 4 is greater than 2, so it will 2, 5 is greater than 4, so it will be 3, like that only. Okay, so I have pre-computed prefix and the suffix. Now I can tell that if this is the peak, okay, peak index. So one thing you should note here is that what is the number of increasing number elements till now? It is I plus 1 because I index is 3, so it is I plus 1, that is 4. and and in the suffix means in the suffix, what is the number of the decreasing, what is the number of decreasing elements till now? So it is n minus I. Okay, so n is 11 and I is 3, so it is 8. So you can see that this is uh, holding both of the condition, so it should be a peak index, so I will return this. So in this way I can just pre-compute. Let's do this. Initially I will assume that all the elements will be 1. Okay, means increase, all the number of the increasing and the decreasing will be 1. I am initializing like that. Okay, now I will pre-compute. If ARR of I is greater than ARR of I minus 1, means it is holding for the increasing order, so I can say prefix of I plus equals to prefix of I minus 1. Similarly, for the suffix 1, I is equals to n minus 2, I greater than equals to 0, I minus minus, ARR of j, if ARR of j is greater than ARR of j plus 1, then I can say suffix of I plus equals to suffix of I plus 1. Okay. So now at each index I have to check what if prefix of I equals to I plus 1 and suffix of I equals to n minus I, then this is the peak index, I can say obviously. Sorry, it was I. Let's submit it. Although it will pass, but the interviewer will not be happy with this solution. Why? Because we can further optimize this. Yeah, that was correct solution. Okay, but we have to do this in big of log time. Okay, so let's again move to that array. Okay, one thing you should move, one thing you should observe here is that uh, before the peak index, before the peak index, this was the peak index. All the entries in the suffix array was 1. Okay, and after the peak index, all the entries in the prefix array was 1. Why it was so? Because I have maintained the array. I have just created that both the arrays in such a manner. Okay, because in the prefix array I am storing the number of increasing elements till now. Okay, till that index, and in the suffix the number of decreasing elements till now. So what I can say is that after the peak index I will not get any decreasing order. That's why it will be 1 in all the entries, and in the prefix array I will not get an increasing element further, because our array is like this. Okay, so if you do not understand, then you should first dry run over this case, or just try to understand. Okay, now I will just use this observation only. Okay, suppose I started at this mid index, then I will just check if it is holding both of the condition, means pre of mid equals to mid plus 1 and sub of mid is equals to n minus mid, then obviously our answer is mid. Okay, but if it is not so, then I will check these two conditions. Either the prefix, if it is prefix of mid is equals to 1, then I should have to move to the left, and if suffix of mid is equals to 1, then I should move to the right. In this way I can do this using the binary search. Okay, so I hope the approach is clear. So let's move on to the solution. Int low is equals to 1. Why low is equals to 1? Because 0 can't be in our answer, and n minus 2 mid, and okay, while low is less than equals to high, mid is equals to low plus high minus low by 2. Okay, if I say if ARR of mid equals to mid plus 1, and ARR of, sorry, it should be suffix and it should be prefix, just in the case like the previous question. Okay, and suffix of mid equals to n minus mid, then this is obviously our answer, return mid. Else there can be two conditions. If pre of mid is equals to 1, then what I have said, if pre is equals to, if, then I should move to the left, so for moving left, high is equals to mid minus 1. Else if suffix of mid equals to 1, then obviously If suffix of mid is equals to 1, then I should move to the right. So it should be low is equals to mid plus 1. So yeah, that's all about the code. Let's run it. It's giving right answer. Let's submit it. So yeah, this will be the optimal solution, which is having the time complexity big O of log n, and obviously we are using space complexity, so it will be big O of n space complexity. Oh, sorry, it will be time complexity and it will be space complexity. Okay, thank you.